Hello, let's continue our Sudoku adventure with Five Arms by James Kopp. So this is just a thermo puzzle. We have normal 6x6 Sudoku rules. That means in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these thermos in the grid. Now the thermos just all overlap, sharing the same bulb cell. But you can think of them as separate thermos. So the way thermos work is whatever is in the bulb, say this was a 2, then we have to strictly increase as we move along. So this could be a 3 or it could be a 4 as long as it's bigger. It just can't be a 1, right? So we could do 2, 4, 5, 6, for example. So you have to keep getting bigger as you go. You can make jumps if able. So we could do 2, 3, 5, 6 as well, or we could do 2, 3, 4, 6. Just have to keep getting better. Can't go back to 2, can't go down to 1, can't repeat. And that's it. Those are, and I guess I should say all of these are separate thermos. So if this is 2, this could be 3, this could be 3. They don't affect each other. They're completely separate. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. Okay, before we pencil anything, I want to look at 1s and 6s because it seems like we have a lot of occupied cells. And so before we make a mess of stuff, 1s can't go on any of these thermocells except for the bulb, because you can't be smaller than the 1. So in order to be strictly increasing, the 1 is restricted to just the bulb. So none of these are 1s. I'm just going to green it. And so in this box, 1's in one of these two. That points in here. That places this 1. That means none of these are 1. Putting a 1 in one of these two. So that's not a 1. Putting a 1 in one of these two. Anything else with 1s? I think that does it. Okay, we're going to look at 6s. 6s can't be on any thermocell except for ends. So none of these are 6s. That puts a 6 in one of these two. That points up saying and down, saying 6s aren't here. So 6s are here and here. 6 is one of these two, so that's not a 6. That places this 6. That's not a 6. Do we get more out of 6s? I don't think so. Yeah, I think that's all we get. But we did place a 1 and a 6. That's nice. Could have just looked at this row for that, but is what it is. Okay, so now I'm going to pencil it. So how do you pencil these? There's a few ways to think about it. One way that I like is I'm going to use this longest one, this 5 length. If we started at if we want to put the bare minimum in each cell starting out. So this is minimum 1, which means this is minimum 2, 3, 4, and 5. Now we reach the end at 5, but the maximum digit is 6. And so we need to add digits until we get to 6. In this case, it's just one more digit to get to 6. And that means all of these get one more digit larger. So this is 4, 5, this is 3, 4, this is 2, 3, this is 1, 2. Another way to think about it is degrees of freedom. So since this is 5 length, it is only missing 1 digit, meaning we have 1 degree of freedom to kind of wiggle around. And so if we start with the lowest digit this can be, it can be 1 higher than it because we have the 1 degree of freedom. So 1, 2, 2, 3, 3, 4, 4, 5, 5, 6. I believe this is also 5 long, so 2, 3, 3, 4, 4, 5, 5, 6. This one is 4 long, so this can be 2, 3, 4, 3, 4, 5, 4, 5, 6. That is a 2, 3, 4 triple here. So this is from 1, 5, 6. So the 2, 3, 4 triple is actually important because they all can't repeat. Like this bulb can't be the same digit as any of these because they're attached to the bulb. You can never repeat digits on a thermo because they have to strictly increase. And so the 2, 3, 4 triple will have a 2 in it, meaning this can only be 1, which is not all that surprising. I don't think I can do more with this 1. Okay, so penciling this one, this is 2, 3, 4, 3, 4, 5, 4, 5, 6. And this can't be 6 because of that 6 there. So that's not 5, that's not 4. That's a 2, 3 pair. So this is from 4, 5, 6. That's a 4, 5, 6 triple. So this can't be 5 or 6. That's a 1. And this is 3, 4. That's a 3, 4 pair. No, not 3, 4. Sorry. This can't be 4. This is a 3. That's 2. That's 3, 4, 5, 6. That's our 6 and 5. That's a 4. 6 and 1 and 5. That's a 6. Okay. That's a 6. Clean up the 3s. This is... Okay, so this has to... Since it's a 4, 5 pair, this has to go 4, then 5. That's 5. This is 2, 3, and 4. Okay. Well, that escalated quickly. We need 2 and 4 here. Oh, right, this 4 looks up. So that's 2, that's 4, and this is 5. Down here we get the 1. Over here we need 2 and 3. Over here we need 2 and 3. This is our 2, that's our 3. Okay, so up here we need a 1. That's our 1. This can't be 3, so that's 2, 3, and 2. Down here we need a 3 and a 4, and we're done. All right, well, that collapsed very quickly once I started penciling. Just a few triples to find. The 2, 3, 4 triple, make that a 1. What's kind of the big one? The 2, 3 pair here made this 4, 5, 6, which made that 4, 5, 6, which gives the 1 and the 3 and the 2. Okay. Cool. Nice puzzle, James. I enjoyed that. Let me know how you did. And if you enjoyed this, why don't leave a like, subscribe, and a kind comment below.